Welcome to Section 12, Wiring Methods. It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how to take this course?
Hi, I'm Cameron, your subject matter professional for this learning. I will help you to understand and be able to apply the requirements of this section of the Canadian Electrical Code Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. This training is divided into topics. These topics build on each other, so a best practice is to review them in the order they are presented. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this Quick Reference Guide to take notes and as a practical job aid for this code section.
Section 12 covers all types of wiring methods required for electrical installations operating at a voltage level of 750 volts or less, with the following exceptions. For voltages in excess of 750 volts, Section 36 may modify these requirements. Class 2 circuits unless specified in Rules 12-2300 to 12-2320. Community antenna distribution and radio and television circuits in Section 54. These are sometimes called coaxial cable installations. Optical fiber cables in Section 56. Communication circuits under Section 60 and conductors in factory-built electrical equipment under SPE 1000. When performing underground installations, there are requirements for how deep the cables and raceways must be. In order to protect electrical equipment from damage due to traffic, Canadian climate, and frost damage, these requirements are outlined in Table 53. Figure 12-2 reviews the installation methods for direct burial, treated wooden planking, poured concrete, and concrete slab. Please note, if the conductors are 1/0 AWG or larger, use IEEE 835 and Rule 4-004, Sub-Rule 1 and 2 to determine ampacity ratings. The underground installation requirements are found in the IEEE Standard or Appendix D, Tables D8 to D11. Raceways, armored or metal sheath cable that is marked to be suitable for direct burial shall be permitted to be installed directly beneath a concrete slab on grade, as long as the slab is at least 100 millimeters thick and the location is marked. Underground raceways and cables must also be protected from movement, settlement, and frost damage. These figures show how to install electric wiring into a building to account for ground movement, specifically by using an expansion joint or PVC sleeving. Here is a short activity to apply what you just learned. Enter your response and select Submit. The column for cables rated 750 volts or less in a vehicular area, and the row for armored cables are selected to get an initial cover requirement of 600 millimeters. Because mechanical protection has been provided, the table value can be reduced by 150 millimeters, resulting in a cover requirement of 450 millimeters. Here is a short activity to apply what you just learned. Enter your response and select Submit. Cables or raceways installed in accordance with this section shall not be installed in locations concealed within a roof decking system, where the roof systems utilize screws or other metal penetrating fasteners. This rule was developed to prevent screws and fasteners from penetrating cables and conduits located within a roof decking system. Time for a scenario. Please read this scenario and follow the instructions to submit your answers. When discussing conductors, this lesson will review some general types and concepts. Non-metallic sheathed cable, mineral insulated and copper sheathed cables, and armored cable. Starting out with insulated conductors. Given the Canadian climate, it is possible that conductors will be installed when it's cold, -10 degrees Celsius or lower. It is important to note if the temperature is below -10 degrees Celsius, the insulated conductor may have to have a cold temperature rating of insulation, either -25 degrees Celsius or -40 degrees Celsius, depending on the ambient temperature of the location. This is because the insulation can become so brittle in cold temperatures that it will crack when it is moved or flexed. If it is likely the conductors will be moved, flexed, or maintained during normal operation in a cold ambient temperature after installation, such as may be the case in industrial or commercial applications such as freezers or sub-zero laboratories, where the conductors must flex. The conductors must have the same temperature rating as they would during installation. Insulated conductors and cables are to be of the type specified in Table 19 for the specific condition of use and location. If there is a possibility of corrosive contact with the insulation, jacket, or covering on a conductor or cable, must be a type that is resistant to the material or protected by a lead sheath or other material that is impervious to that corrosive material. Time for another scenario. Please read the scenario and follow the instructions to submit your answers. Parallel runs, or conductors in parallel, are used to distribute the load evenly between several smaller conductors. There are several requirements for this setup. They can be used when the conductors are sized 1/0 AWG or larger. The conductors must share the load current equally. They must be free of splices throughout their length. A single splice per termination point is allowed in order to meet the requirements of Rule 4-006, and where spliced in the same manner, be the same size, have the same insulation, terminated in the same manner, made of the same conductor material, and are the same length. Parallel conductors in the same phase, polarity, line, or the grounded circuit must have the same characteristics. However, if the conductors have a different phase, polarity, line, or ground circuit, they may be different. These tables show examples of both of those situations. Installations involving aluminum conductors are used because they are inherently lighter and less expensive than equivalent ampacity copper conductors. One of the downsides with the use of aluminum conductors is that aluminum begins to oxidize as soon as it's exposed to air. Insulation is removed from the conductor. Oxidization on the conductive surface increases the resistance at the point of termination, which can result in excessive heating. To prevent the oxides from forming when terminating or splicing aluminum conductors, the conductive surface must be cleaned with a wire brush to remove any oxidization, coated with a joint compound such as Nolox to prevent oxygen from contacting the aluminum, and used only with fittings approved for termination of aluminum conductors. To account for aluminum and copper expanding at different rates, when field mounting aluminum lugs to copper or aluminum bus bars, washers must allow for the different expansions of the metals involved. Note that a minimum of 9.5 mm or 3/8 inch stud or bolt be used to make the connection. conductors are run vertically in conduits for longer runs, the sheer weight of the conductor can put stress on the termination and insulation and cause damage. It is therefore required that conductors be supported within vertical raceways at intervals not exceeding those in Table 21. One common method of providing support for conductors inside a raceway is to use an insulated wedge support. This is when a pull box is placed in the conduit at an interval determined by Table 21. The wedge support, a piece of rubber sized for the conduit and the conductors contained within, is split in half and fitted around the conductors after they have been pulled into the conduit, and wedged into place in the opening of the bottom conduit entering the pull box. Armored or sheathed cables such as Tech 90, RA 90, RC 90, AC 90, and ACWU 90 must have their interior cable assemblies supported when making long vertical runs. Since supporting the inside conductors in an armored cable is not an entirely easy prospect, there are methods in this rule that can be used for support. They are, if there is either the equivalent of a 90-degree bend at intervals specified by Table 21, the horizontal cable run is greater in length than the vertical run, or the cable is specifically designed for vertical runs, such as cables used in the mining industry. Cables must be supported but cannot be damaged by the supporting process. Approved straps, cable ties, specifically approved for the purpose, and other devices are allowed to be used at the intervals specified by the code. Note that cable ties have a variety of different purposes when it comes to wiring, and they are used in several areas within the code, which are listed here. For more information, see Appendix B. Note to Rule 12-510, CSA C22.2, number 62275, is the standard that describes the requirement for cable ties. Also, note that cable ties are allowed to support flexible conduit and flexible tubing. The types of cable ties are approved to provide primary support for flexible conduit, flexible tubing, or cable within electrician work. They are Type 2S and Type 21S. Type 2S and 21S are types of cable ties that are specifically approved for primary support for flexible conduit, flexible tubing, or cable. Due to the size of some of the cable ties, the marking may not appear on the cable tie but will be on the packaging. When non-metallic sheath or armored cable is run through or along studs, joists, or similar members, it must be protected from damage from the location or other mechanical means. This is done by keeping the outer surfaces of the cable at least 32 millimeters from the edges. If the cable is closer, it must be protected by a protector plate or inside of a cylinder bushing designed for that purpose. The cylinder must extend at least 13 millimeters beyond the edge of the stud on both sides. Armored cables come in a number of different varieties, including Tech 90 and AC 90. Table 19 outlines which types of armored cables are suitable for installations both above and below ground. When terminating armored cables such as AC 90, the conductors must be protected where they extend beyond the armor by use of a bushing or anti-short as shown in the picture. When terminating Tech 90 armored cable, the inner jacket of the armored cable must extend at least 5 millimeters beyond the armor. If a conductor is a number 8 AWG or larger, copper or aluminum, use the following for protection: an insulated bushing or hubs with smooth rounded throat, or insulating materials separating the conductors from the armored cable. The next area of wiring methods to be reviewed are raceways. These are channels designed for enclosing and loosely holding conductors, cables, or busways. This includes metal or non-metallic, and conductors or cables that are pulled or laid in. The following will be reviewed related to raceways. According to Table 19, armored cables are not approved for use in raceways. This is because armored cables, by design, already have the required mechanical protection for a given installation, and because the armor could be damaged if drawn into a raceway, especially around tight bends. That said, the code recognizes that there are times when it may be desirable to install an armored cable inside a conduit, perhaps in a pipe chase through a concrete wall from one area in a building to another. If armored cable is used, the conduit must meet the following criteria: a minimum radii of at least 0.944 meters for cable rated 1,000 volts or less, and 1.524 meters for cable rated in excess of 1,000 volts. Is limited to a maximum length run of 15 meters for a 3-conductor copper cable, 45 meters for a single-conductor copper cable, 35 meters for a 3-conductor aluminum cable, or 100 meters for a single-conductor aluminum cable. Lastly, the run of conduit or tubing between draw-in points does not have more than 2 90-degree bends. When conductors are installed in the same raceway, they must be connected to the same power and distribution transformers or other type of sources of voltage. There are some exceptions to this rule. For example, if the conductors run in that cable tray meet the requirements of Rule 12-2202, the conductors are separated by metal armor or metal sheath of cables in Table 19. Conductors are separated by 1.34 millimeters of sheet steel or 1.5 millimeters of flame-retardant non-metallic insulating material. Lastly, if it is used to supply or control devices and equipment that are interconnected and insulated for the highest voltage present. Also, none of the lower voltage conductors can be directly connected to a lighting branch circuit. The maximum permitted number of insulated conductors of the same size in one HDPE conduit can be determined from Tables 9A through 9H. This number should be determined by using the method for Tables 8, 9A to 9H, and 10. Let's work through this example. Review each step and think about what your answer would be. Then click the Answer button to reveal the answer. What is the minimum trade size of electrical metallic tubing required for a 3-phase, 4-wire feeder using a 4-aught AWG stranded T90 copper conductor? There are a variety of types of raceways. The types listed will now be reviewed, focusing on restrictions on use, bonding requirements, support requirements, splices, and other special considerations. Rigid conduit is one of the most rugged and durable raceways used in electrical installations. Manufactured of thick wall steel or aluminum, rigid installations provide a high degree of mechanical protection, good electrical continuity for a bonding path throughout the length of the conduit, and an overall solid installation. Rigid will often be used in industrial areas subject to mechanical injury, hazardous locations, and outdoors, in environments where PVC is not suitable. The code outlines restrictions on the use of rigid metal conduit. When they are used in damp or wet conditions, the conduits are to be threaded, and the threaded joints and fittings need to be watertight. Table 40 can be used to determine the threading requirements. The minimum size is 16. The rigid conduit can be the bonding conductor unless these conditions apply. All rigid metal conduit of one size must be securely attached to hangers or to a solid surface. The maximum spacings of the points of support not greater than the requirements shown here. Splices are not allowed with rigid metal conduit according to Rule 12-912. Flexible metal conduit, commonly referred to as flex, is typically reserved for short runs requiring flexibility, such as motor installations. Trade size 12 is used only for connection to equipment in lengths not exceeding 1.5 meters. Always in flexible conduit sized using table 16. Support the conduit within 300 millimeters of the box and every 1.5 meters of length. Splices are not permitted according to Rule 12-912. Rigid PVC is a conduit system often used in wet locations and in underground applications often encased in concrete. Rigid PVC conduit cannot be used where it would be subject to temperatures in excess of 75 degrees Celsius. It must have an FT4 rating in buildings that are a non-combustible construction. It cannot be enclosed in thermal insulation. Use Table 16 to size bonding conductors. The following is the maximum amount of space between points of support for rigid PVC conduit. Splices are not allowed according to Rule 12-912. There are many special considerations for rigid PVC conduit. Although it is a rigid material, it must be protected from damage. If damaged, to repair damaged conduit without removing existing wiring, use split-straight conduit. However, the following requirements must be met. Cut the wiring to ensure the integrity of the raceways and join with PVC solvent cement. If an end is not equipped with an attached ball adapter, it needs to be fixed with split couplings applied with PVC solvent cement. Each part of the split-straight conduit and split coupling is tightly clamped at both ends. Any additional clamps cannot be more than 500 millimeters apart. Non-removable band clamps are made of stainless steel. The insulation of conductors in the raceway is not damaged. It may not be used in insulated wall spaces or attics where embedded, and must be joined and terminated only with approved fittings and adapters. Because PVC material cannot provide a bonding path, a separate bonding conductor must be installed in all runs of rigid conduit to ensure the system bonding continuity. It should also be noted that manufactured bends may be used, but that it's also permissible to do field bends, provided that the right equipment is used. The right equipment consists of heat guns, hot boxes, and heating blankets, as opposed to the wrong equipment such as propane torches, barbecues, and exhaust pipes on the service truck. All building materials will expand and contract with temperature change. With materials such as rigid PVC, the amount of expansion is almost 5 times that of metal materials like steel rigid. The code requires that a run of PVC conduit be limited to 45 millimeters of expansion before an expansion joint is required. When expansion exceeds 45 millimeters, expansion joints must be installed to ensure the conduit doesn't break as a result of expanding and contracting. Appendix B contains a chart showing the coefficient of linear expansion in millimeter per degree Celsius for various building materials and conduit types. In order to calculate the linear expansion of a given conduit run, the distance is multiplied by the temperature range and the coefficient of linear expansion. Here is a short activity to apply what you just learned. Enter your response and select Submit. In this example, the run of PVC conduit is 50 meters long, installed in an area with a temperature range of minus 25 degrees Celsius to plus 35 degrees Celsius. Using the coefficient of linear expansion from Appendix B for PVC conduit, it is determining that the total conduit expansion will be 156 millimeters. Because Rule 12-1118 limits expansion to 45 millimeters, 45 is divided into the total expansion of 156 millimeters. EB1 and DB2/ES2 PVC conduit is to be used for underground installation following Rule 12-930. Type EB1 conduit is laid embedded in at least 50 mm envelope of masonry or poured concrete. They are not permitted to be installed above ground except where permitted by Rule 12-1150. Must use a bonding conductor unless as part of a service. This would make the grounded conductor act as the bonding conductor. Splicing is not permitted. Rigid RTRC conduit types AG, BG, and XW are used underground and in walls, floors, and ceilings, where it is encased or embedded in at least 50 mm of masonry or poured concrete. Liquid-type flexible metal and non-metallic conduit is used where a flexible connection is required in dry, damp, or wet locations. Cannot be located somewhere where it's exposed to mechanical damage or where it would be exposed to gas or other light petroleum solvents, corrosive liquids, or vapors. Additionally, it cannot be in temperatures above 60 degrees Celsius. Lastly, it cannot be where flexing at low temperatures might cause injury. It must be used in runs of less than 1.5 meters of 12 trade size to connect equipment. Liquid-type flexible conduit can also be used for direct burial in accordance with Rule 12-012 and where specifically approved and marked for that purpose. Bonding conductors are sized using Table 16. In order to support this type of flexible conduit, use straps or other devices that are within 300 mm of every outlet box, junction box, cabinet, or fitting, and be sure that each support is no more than 1.5 meters apart. If providing this support is impractical, the code permits this type of conduit to be fished. No splices are permitted according to Rule 12-912. Is allowed to be used as general-purpose raceways. Moving on to electrical metallic tubing, commonly referred to as EMT, electrical metallic tubing is metallic raceway that has a circular cross-section that conductors are drawn into and out of. EMT is one of the most popular conduit choices for general installations in commercial, institutional, industrial, and even high-density residential construction. There are, however, limitations on the uses of EMT. It may not be exposed to mechanical injury before or after installation, used in areas exposed to corrosive vapors, directly buried in the earth or in wet locations. It may be installed in concrete or masonry slab, or wet locations, but a separate bonding conductor must be installed, as over time, the concrete will eat away at the metal until it's no longer a reliable bonding path. When Section 10 requires bonding, a separate insulated bonding conductor must be installed in electrical metallic tubing that is installed in any of the following locations: concrete or masonry slabs with contact with the earth, wet or outdoor locations. When used as a consumer's service raceway between the service head and a meter mounting device or service box, bonding is in accordance with Rule 10-606 unless it requires a separate bonding conductor as mandated in other sections of the code. The support requirements are the same as rigid metal conduit as shown here. Splices are not permitted according to Rule 12-912. The fittings used for EMT are determined based on the environment the conduit will be installed in. If embedded in concrete or masonry, the conduit must be joined with concrete-type fittings to prevent concrete or grout from seeping in and filling up the conduit. If exposed to the weather, in some cases is exposed to sprinkler pipes, wet location fittings are required. In all ordinary locations, standard fittings may be used, although it is still permissible to use concrete on rain-tight fittings in these locations as well. According to Section 10, EMT may be used as a bonding path. However, it is important to ensure that the fittings are securely fastened to provide a reliable bonding path. Many engineers and contractors opt to install a separate bonding conductor to ensure that a small error on the part of a field installer doesn't result in a compromised bonding path. Electrical non-metallic tubing, or ENT, is a pliable, non-metallic corrugated raceways of circular cross-sectional shape. ENT must be used with mechanical protection if it is subject to damage either during or after construction. ENT must be supported within 1 meter of an outlet box, junction box, cabinet coupling, or fitting. There cannot be more than 1 meter between supports. ENT tubing cannot be used where the normal temperature will be in excess of 75 degrees Celsius. Moving forward to surface raceways. Surface raceways, like those manufactured by wire mold, are channels that are mounted on the surface of walls, ceilings, and floors. They are handy for additions to an installation where the wall structure, such as concrete, cannot be fished, and for installations that require a degree of flexibility throughout their lifetime. Surface raceways can only be used in dry locations where they are not subject to mechanical damage. They must have the appropriate FT rating and cannot be extended through walls, partitions, and floors. Surface raceways are to be supported in accordance with the manufacturer's requirements. Splices are allowed if the raceway has removable covers. Auxiliary gutters are used to supplement the wiring space of meter centers, switchboards, and control centers. They are made of sheet metal and may not be longer than 6 meters. The gutter may not be used to enclose bus bars, switches, overcurrent devices, or other equipment, as it has not been tested or approved for that purpose. If the gutter does extend beyond 6 meters, it is then considered to be a wireway, and must conform to the requirements of a wireway, which will be reviewed next. Auxiliary gutters need to be supported at intervals less than 1.5 meters. Splices are permitted. See Rule 12-2018. Wireways are metallic troughs with removable covers. The following are the requirements when working with wireways. They are used for exposed work, but not commonly found in areas where aesthetic appeal is important. A common application is to have wireways run across a series of control cabinets, making it easy to add or remove conductors between the cabinets at any time throughout the lifetime of the installation. Wireways may not be installed in areas subjected to mechanical injury or corrosive vapors. The number of conductors in a wireway is limited to 200, with a maximum fill of 20% of the trough's cross-sectional area for power and lighting conductors and 40% of the cross-sectional area for signal and control conductors. Must be supported at no more than 1.5 meters unless it has been approved for greater lengths. Splices are allowed according to Rule 12-2106. Cable trays offer an economical and sturdy support structure for service, feeder, and branch circuit cables, mostly used in industrial, commercial, and institutional construction. The code does not give specific support requirements for cable trays. Instead, it requires that cable trays be marked with the applicable load and span ratings, as determined by testing to the Part 2 standard. Cables must be listed as approved for use in cable trays in Table 19, and will either have a continuous metal sheath, interlocking armor, or be marked as Type TC, tray cable. In order to use a TC, tray cable, in a cable tray, it must be in industrial areas that are not accessible to the public. Additionally, the cable must be installed in a conduit, suitable raceway, or directly buried when not in a cable tray, have mechanical protection if it is subject to damage during or after installation, be no smaller than number 1/0 AWG when a single conductor is used, and be installed only where a qualified person can service the installation. For more information, see appropriate sections of the code for restrictions of use. Bonding conductors are sized using Table 16 and bonded at intervals of less than 15 meters or bonded with metal supports that are in contact with grounded structural metal of the building. A bonding conductor is sized with Table 16 using the ampacity of the largest ungrounded conductor of the circuits in the tray. For a metal cable tray, it does not need to be bonded to the ground when all of the cables in the tray have interlocking metal armor or have continuous metal sheath that is permitted to be used as a bonding method. Any cable tray that is not bonded must have a written warning stating interlocking metal armor cables or continuous metal sheath cables only. This message must be placed in an obvious place with more warning spaced no more than 10 meters away. Use the load rating of the cable tray. Conductors and cables installed in a cable tray are to be fastened to the tray at intervals of less than 1.5 meters throughout the run. Type TC-ER or extended run tray cable is permitted to transition from cable trays and between cable trays and utilization equipment for up to 1.5 meters without support and up to 7.5 meters with support. Conductors and cables inside of cable trays need to be fastened at intervals of no more than 1.5 meters. This is due to movement that occurs due to magnetic forces during a fault. Additional consistent spacing between conductors and cables is required to maintain ampacity values. Splices are permitted according to Rule 12-2204. There are many special considerations for cable trays. This diagram outlines the clearance requirements for cable trays outlined in Rule 12-2200. It is important that cable trays generally be accessible from at least one side and have sufficient clearance above to ensure the cables can be installed without sustaining injury, as well as securely fastened in place after installation in order to maintain required spacing. With modular assemblies such as natural gas compressor station and gas plants, customers may want a cable and cable tray wiring method. However, because of the clearance requirements in Rule 12-2200, it is difficult if not impossible to maintain those clearances. However, Sub-Rule 7 allows cables to have reduced clearances through chases, under gratings, and process pipes. Cable bus is defined by the code as an assembly of insulated conductors with fittings and conductor terminations in a completely enclosed, ventilated, or non-ventilated protective metal housing. It is an engineered product and must be installed as per the manufacturer's drawing and specifications. Deviations are not permitted. Cable bus is usually assembled where it will be installed. This includes components provided or specified by the manufacturer for that job. Here is a short activity to apply what you just learned. Enter your response and select Submit. The last topic in this lesson is outlet boxes, cabinets, outlets, and terminal fittings, starting with outlet boxes and covers. Outlet boxes must be installed at every point of outlet, switch, junction of conduit, raceway, armored cable, or non-metallic sheathed cable. Outlet box covers must be installed on flush-mounted boxes and surface-mounted boxes. Use each for the purpose it was designed for. Always make sure that an outlet box that requires wet location cover plates is installed in a way to ensure a seal between the outlet box and the cover. Always use the correct type of flush boxes, cabinets, and fittings. To determine the number of insulated conductors, use Table 23. There are conditions where the maximum number must be reduced. Reduce by one insulated conductor if the box contains one or more fixture studs or hickeys. Also, reduce by one insulated conductor for every pair of conductor connectors with insulating caps, or two insulated conductors if the box contains one or more flush devices mounted on a single strap. If a box has a device that has a dimension greater than 2.54 centimeters between the mounting strap and the back of the device, calculate the usable space by 32 cubic centimeters multiplied by the depth of the device in centimeters. To calculate the size of a box for a polar junction box, the diameter of a cable is the same as the trade size of the raceways that would be required to have the same size and number of conductors in the cable. The following are examples of this calculation. Take a moment to review the graphic. Time for a final scenario. Please read the scenario and follow the instructions to submit your answers. Time for a final scenario. Please read the scenario and follow the instructions to submit your answers.
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section. You have now completed the learning on the main concepts and requirements of this code section. Next, you will take the open book quiz through the link on the course page. Click Close to exit, and then start the quiz.